Okay, let's unpack this. I want to start with a paradox. It's a situation that, honestly, it shouldn't exist based on how we usually think about intelligence. Imagine you have a checklist for a child's development. Hearing,
Perfect.
passes every screening. Nonverbal IQ,
Totally normal, maybe even above average.
socially, they want to interact, they're making eye contact, they're engaged, there's no brain damage, no autism context, but then you ask them to tell you what happened at school yesterday.
And the wheels just come off.
Completely. The sentences chop up, essential little words go missing.
Yeah.
I mean, it sounds like a toddler talking, even if the kid is 7 or 8 years old. And the parents are baffled because they know he's smart. They know he hears them. This is the confusing world of specific language impairment, or SLI.
Which, ironically, is a label that tells you exactly what it is and yet explains almost nothing about why it is. It's one of the great cognitive mysteries.
And that's our mission for this deep dive. We're looking at the research, specifically the cognitive and linguistic perspectives, to figure out how a brain can be so competent at everything else, but seemingly broken when it comes to grammar.
Yeah.
It really challenges the whole idea of how we learn to speak in the first place.
It does. And before we get into the theories, we have to be really clear about that specific part of the name. I mean, it's the diagnostic criteria that makes this so baffling. To get an SLI diagnosis, you actually have to rule out almost everything else first.
So it's a diagnosis of exclusion.
Exactly. If a child has hearing loss, it's not SLI. If they have frank neurological damage, like from a stroke or a traumatic brain injury, it's not SLI.
Yeah.
And this is the big one people often confuse it with. It's not autism.
Right, because kids with autism often have language struggles too.
True, but the profile is totally different. Children with SLI don't have the primary social withdrawal or the repetitive behaviors you see with autism. They want to communicate, they just don't have the tools to do it structurally.
So their primary deficit is the code of language itself.
The code itself, yes.
But looking at the history here, we haven't always called it SLI. The sources mention this condition has been recognized since, the mid-19th century?
Oh, we've been trying to name it for a long time. And the old names are fascinating because they reveal what doctors thought was happening. They used to call it congenital auditory imprecision, basically blaming the ears, assuming the kids just weren't hearing the details, or congenital aphasia, assuming he was like a stroke victim, but, born that way.
The one that's stuck around the longest, though, and the one the research seems to hate the most, is delayed language.
Ugh. That term is actually quite dangerous.
Why? Delayed just sounds like they're on a slower schedule.
Precisely. It implies a slow start. It suggests, don't worry, he's just a late bloomer, he'll catch up eventually. It comforts the parents, but it's scientifically misleading. The research is clear. For the vast majority of these kids, without significant intervention, they do not simply catch up. It's not a delay, it's a deficit. It's a persistent struggle.
And it's not rare, is it? I was actually shocked by the numbers in the briefing.
It is surprisingly common. I mean, epidemiological studies put it at about 7% of the population.
7%, that's massive. In a standard class of 30 kids, that's 2 children.
Exactly. And think about how often we talk about dyslexia or autism. SLI is just as prevalent, if not more so, but it just flies under the radar. There is also an interesting demographic skew. It hits boys harder.
The classic gender gap.
Yep. In clinical settings, meaning kids whose parents take them to a doctor, you see about 2.5 boys for every girl. In the general population studies, it's a bit more balanced, maybe 1.5 to 1, but still a clear male dominance.
Which brings us to the cause. If it's not bad parenting, and we know it's not that, and it's not ear infections.
It's almost certainly genetic. The heritability estimates are very high. If you have SLI, you are 2 to 3 times more likely to have a family member with language issues compared to a typical child.
And I assume twin studies back that up.
They do. Identical twins show a much higher concordance rate, meaning if one has it, the other likely does too, compared to fraternal twins. So the hardware is, well, it's pre-wired this way.
Okay, so let's talk about what this actually looks like in real time. Because if I'm a parent, what am I seeing? The text used this phrase I loved, language development in slow motion.
That's the perfect visualization. Everything happens just later.
So first words are late.
Late. That vocabulary explosion toddlers usually have around 18 months where they learn a new word every few hours. It's a slow, painful burn for these kids. It takes them ages to get from 1 word to 50 words.
And usually they understand more than they can say.
Usually.
Yeah.
Though not always, and we should be careful there. But yes, the gap between comprehension and production is often what frustrates the parents. The kid knows what they want to say, they understand the question, but the output mechanism fails.
And this doesn't stop at preschool. This isn't just baby talk.
No, it persists into adulthood. But the biggest secondary casualty, the thing that really impacts their education, is reading. There is a massive overlap between SLI and dyslexia.
Help me parse that, because I think people use those terms interchangeably.
They are cousins, but not identical twins. Dyslexia is typically a phonological issue, trouble mapping sounds to letters.
Okay.
Kids with SLI often have that phonological weakness too, but they also have deep deficits in semantics meaning and morphosyntax grammar.
So a kid with dyslexia might struggle to sound out the word. A kid with SLI might sound it out, but not understand how the grammar connects the words.
Exactly. You might have a kid with SLI who can decode. They can read the words out loud perfectly, but they have zero idea what the sentence means because the grammatical structure went right over their head.
That's a silent failure. You'd never know until you tested their comprehension.
And those are the kids who fall through the cracks in 4th or 5th grade, when reading shifts from learning to read to reading to learn.
Okay, let's drill down into the core glitch here. The sources keep coming back to this term, morphosyntax. That sounds like the villain of our story. What exactly is going on there?
It's the intersection of morphology, the little parts of words, and syntax, the sentence structure. Specifically, in English-speaking children, the hallmark struggle is with tense and agreement.
So knowing when something happened and who did it.
Right. The little markers, the ed on walk to show past tense, the s on he walks to show third person singular.
Yeah.
The verb to be, like is or are.
The sources highlighted something fascinating about the type of errors they make. It's not that they use the wrong word. They aren't inventing new endings.
Correct. It's an omission error, not a commission error. A child with SLI won't say they jumps. That's a commission error using the wrong marker.
Instead, they'll just say,
they jump. Or, Daddy walked to work yesterday.
They strip the sentence down to the bare stem.
They do. It's like they're telegraphing. They drop the expensive grammatical bits and just keep the main content words.
But here's the part that drives me crazy, and I assume drives researchers crazy too. They don't do it 100% of the time.
That is the variability puzzle. If they missed it every single time, we'd say, okay, simple. They don't know the rule. They don't know that ed means past tense.
But they do use it correctly sometimes.
Sometimes. And sometimes they even over-regularize.
Right. They'll say runned or throwed.
Which proves they know the rule.
Yeah.
You can't say runned unless you know that adding ed makes it past tense. You've never heard an adult say runned.
You had to invent that using the rule.
Precisely. So the knowledge is in there. They possess the abstract rule. But they can't access it or apply it consistently. And that inconsistency is what has split the scientific community into two warring camps trying to explain it.
The knowledge camp versus the processing camp?
The battle of the theories.
Okay, let's start with the knowledge camp. This is the linguistic approach. Their argument is that the grammar software itself has a bug.
Or rather, that the software is stuck on an old version. The most famous theory here is the extended optional infinitive stage.
Unpack that for us.
Well, the idea is that all children, even typical ones, go through a phase where they think tense markers are optional. A normal 2-year-old thinks daddy walk and daddy walks are both valid ways to speak.
But normal kids figure out pretty quickly that daddy walk is wrong.
Right. They update the software. They realize, oh, in English, tense is mandatory. The theory is that children with SLI get stuck in that optional phase for years. Their brain doesn't flip the switch that says tense is required.
And there's a mechanism proposed for why they get stuck called the unique checking constraint. This got pretty dense in the reading, so let's simplify. Is this basically a bottleneck?
Think of it like a quality control checkpoint in the brain. To produce a grammatically correct sentence like he plays, your brain has to check 2 boxes simultaneously. Box 1. Tense is happening now. Box 2. Agreement. Is it singular or plural?
2 stamps of approval needed before the sentence leaves the lips.
Exactly. The theory says children with SLI have a constraint where they can only check 1 box at a time. The system gets overloaded. It can't handle the double check.
So the brain goes, I can't do both, so I'm just going to ship the sentence without the timestamp.
Precisely. It defaults to the simpler version. And here is the killer piece of evidence for this theory. The thing that makes linguists get really excited.
What's that?
This theory predicts that this error should only happen in languages where you need to check both boxes.
Like English?
Like English. But take a language like Spanish or Italian. In those languages, you can drop the subject. You can just say, dormo, for I sleep. Because of how that grammar works, you don't have the same double check conflict.
So, do Italian kids with SLI make these errors?
They don't. They do not drop the tense markers. The theory successfully predicts that Italian kids won't say dorm instead of dormo. It's a huge win for the linguistic camp because it suggests the problem isn't just being slow, but a specific interaction with the rules of grammar.
Okay, so that's Camp 1. The rules are broken, or the constraints are too tight. Now, Camp 2, the processing approach. They say, the rules are fine, but the computer is too slow.
This is the general slowing hypothesis, and general is the key word here. We tend to think of SLI as just a language problem, but researchers started asking, what if we test these kids on completely nonverbal stuff?
Wait, what?
Like mentally rotating geometric shapes. You show them a shape and then a rotated version and ask if it's the same shape. No words involved.
And the SLI kids struggle with this.
They are significantly slower, about 14 to 33% slower than typical kids. And it's a linear relationship. The harder the task, the more you have to rotate the shape, the slower they get compared to their peers.
So the clock speed of the CPU is just lower. It's not about words, it's about processing information.
That's the argument. And think about language. It is the fastest, most complex signal the brain ever has to process. It comes in, it's gone in milliseconds, and you have to decode sound, meaning, and grammar instantly.
If your processor is lagging by 30%, you are going to drop packets of data.
Exactly. You're buffering.
Yeah.
And the packet that gets dropped is usually the most fragile, least essential part. Which brings us to working memory.
The phonological loop.
Yes. This is the brain's audio buffer. It holds words while you figure out the sentence structure. Children with SLI have a terrible time with this. There's a test called non-word repetition, where you ask them to repeat nonsense words like blonderstaping.
Blonderstaping, okay.
As the words get longer, SLI kids fall apart. They can't hold that sequence in their memory long enough to repeat it. Their buffer is leaky.
But I have to play devil's advocate here, and the sources did too. If everything is slow, why is it just the tense markers that vanish? Why don't they forget the word dog?
Exactly.
Why is the deficit so specific to these little grammatical endings?
That is the valid critique. If the slowing is general, the failure should be general. Why is mommy preserved but drives becomes drive?
So how do we reconcile these? We have one theory that explains the specific grammar errors but ignores the slowing, and another that explains the slowing but struggles with the specificity.
Well, we look at the English is hard problem, or rather, the English is messy problem. This is where the cross-linguistic evidence saves us.
This was the comparison with Swedish, right?
Yes. Swedish and English are cousins, both dramatic, both tricky. But Swedish children with SLI are actually better at past tense than English children with SLI, even when they're matched for severity.
Why? Is Swedish grammar easier?
It's about the signal strength of the rule. English grammar is incredibly inconsistent. We have so many bare stems. I walk, you walk, we walk, they walk. The word walk doesn't change.
Right.
We only add the S for Heyscheit.
So the rule only applies sometimes.
Right. The signal is weak. In many other languages, the verb always changes. The signal is loud.
So in English, it's harder to hear the rule in the first place.
Exactly. Now, combine the two theories. Imagine you have a slow processor. That's theory 2. And you are trying to learn a language where the data is messy, inconsistent, and hard to spot. That's the English problem.
It takes you much, much longer to gather enough statistical evidence to realize, oh, I actually need that ed.
That's the synthesis.
Yeah.
It's the interaction between a slow brain and a messy language. If you have a slow processor but a loud language like Italian, you might be okay. If you have a fast processor and a messy language like English, you figure it out.
If you have both.
If you have both a slow processor and a messy language, that's where SLI manifests as this specific grammar failure.
That makes so much sense. It explains the variability, too. They are building the database, but it's just taking forever.
And we have proof that the knowledge is there, just hard to reach. The Grinch experiment.
I loved this study. Syntactic priming.
Right. They showed kids a picture, say, the Grinch is reading. But before the kid speaks, the researcher primes them by having them say a similar sentence like, the cats are drinking.
Warming up the engine. Greasing the specific grammatical pathway.
Exactly. And when they did that, the SLI kids suddenly used the is correctly.
Yeah.
The error rate dropped significantly.
So the general slowing makes it hard to retrieve the rule from the messy database, but if you give them a boost to prime, they can do it.
Exactly. It suggests the grammar isn't missing, it's just expensive to process. The priming lowers the cost of retrieving that structure.
This really shifts how you view these kids in a classroom.
It has to. If you're a teacher or a parent, you have to realize This isn't laziness. It's not tuning out. It's not defiance.
I keep thinking about the analogy of the manual transmission.
It's a good one. Most of us speak on automatic.
Mm-hmm.
We don't think about adding an ed. It just happens. These children are driving a manual transmission in an automatic world.
Wow.
Every single grammatical agreement requires a conscious mental gear shift.
Okay, it's he, so I need an S. Okay, it's past tense. I need an ed.
And that burns energy. It's exhausting. And if the input is coming too fast, if the teacher is speaking rapidly, the kid is still trying to shift gears on the first sentence while the class has moved on to the third.
It makes you wonder about the nature of talent. We usually think of being good with words as this high-level, almost artistic trait. We think of poets and orators as having these special souls. But looking at SLI...
It brings it down to earth, doesn't it? It suggests that what we call innate talent for language might just be the result of a highly efficient processor.
Right. Maybe a poet is just someone with a really fast phonological loop.
It's a provocative thought. If you slow down the clock speed just a little bit, the language instinct, what we think makes us human, starts to crumble.
Yeah.
It shows us just how fragile and how mechanical our humanity really is.
A humbling takeaway from a fascinating condition. That's it for this deep dive into specific language impairment. Hopefully, the next time you hear a child struggling to get a sentence out, you'll have a bit more appreciation for the complex machinery grinding away under the surface.
Thanks for listening.
See you on the next one.